Hey programmers, welcome back to Software Developer Diaries. And as you saw from the video title, our today's topic is going to be this anti-corruption layer. But please bear with me because I want you to actually forget about it for the next 2 minutes because I want to give you some context, all right? So imagine we have our system and it's basically a microservices architecture. We have microservices or services connected to their respective data store and databases, and everything kind of looks fine. And we are a business, let's say we're an e-commerce business, and for some reason or at some point, we realize that our system is actually crap. It's not scalable, the code is really bad quality, and we need to do something. So senior engineers and the management finally decide to start migrating this big mess into a cleaner architecture. And this cleaner architecture lives here in the new system. Now, as you know, the business is running, so we cannot simply tell developers, hey guys, you have 6 months to rewrite the whole application. No, it doesn't work like this. We start migrating services one by one. So let's say we take this service and we migrate it here into the new system, and we make sure that we follow the best practices that we at least know to this date. And now our new system is actually much more performant and we have our respective databases. But here's the problem. Our new service is here, but we still are relying directly on our old microservices. Let's say this is a payment service which still lives in the old system. Now, how does the new system connect to or talk to the microservice in the old system? Well, you can say, why not? They can just talk directly. Actually, the answer is no. If we decided to migrate to a new system and we have a direct relationship with or direct connection to one of the microservices from the old system, which we actually label as corrupted, C for corrupted, if we rely on one of these guys, then our new system is also corrupted. Okay? Bad plus bad equals bad. We don't want that. We want to have no relationship with the corrupted system. So what do we do for that? Let me revert these lines so that we have a better overview. As you can see, we actually introduce an anti-corruption layer. An anti-corruption layer acts as kind of a middleman, kind of an aggregator, kind of an API gateway, if you want me to say that. It's kind of an API gateway for the old system and their microservices. So the new service is basically going to talk to the anti-corruption layer, and then anti-corruption layer is going to trigger one of these microservices, let's say this one, to get the data for the new service. And this way, we no longer have a direct dependency to our corrupted system and its convoluted schema, bad code, and kind of badly architected microservices and APIs. All right, our new system is the cleanest and we are following the best practices from now on. Now, I have to also say that anti-corruption layers, so this guy, is not only used during migrations. Okay, you can use them for migrations, meaning as soon as you're done migrating all of these services, you're going to get rid of the anti-corruption layer and you're good with your new system. That's not the only use case, although it is one of the primary use cases. The second use case is actually when your system simply talks to one of the third-party systems, maybe even outside of your organization. I personally had this experience when talking to one of the government-related APIs, and their API was really weird. Their API was not following the best practices. So in order not to rely on this weird API, I had to introduce an anti-corruption layer, which was taking my requests and kind of mapping them into this API, taking the response from this API and kind of sanitizing them or mapping them in a better way and returning them to my API. So this anti-corruption layer is basically a piece of code, or can also be a microservice on its own that basically sits between another service and your system or your microservices that are in the new system. Okay, now you're probably wondering, what does the code look like here? Let's say if it's a service on its own. Well, the answer is it's basically a facade or adapter pattern that you know from design patterns. And the design pattern is basically this. In JavaScript, let's say, we would have 3 microservices, CPU, memory, and hard drive, and they have their own respective methods. And these are literally our old services. We can call them our old services because these guys are kind of low level, all right? Now, facade in this case will be the anti-corruption layer that we have here. What it does, it simply encapsulates these 3 classes in the constructor and it provides a new method, start, which is going to, under the hood, trigger all these class methods. And here, the computer, which directly correlates to our new system, this computer is only going to call start, and under the hood, the facade is going to take care of everything else. So this is the code that you basically need to know in order to succeed with the anti-corruption layer. Now, here are some questions and these questions are very valid. For example, the anti-corruption layer may add latency to calls, because you need to consider that if you have an anti-corruption layer, this is basically another microservice that sits on your way to another service. So it's going to add some milliseconds to your time. So be careful with them and get rid of it as soon as the migration is done. The second point is that anti-corruption layer adds an additional service that must be managed. This microservice doesn't come for free. You also need to manage it and make sure that it always works. Also, consider how your anti-corruption layer will scale. Because if you configure scaling for these microservices here, but forget about this one, this is going to be a bottleneck. So you have to make sure that you scale these anti-corruption layers as well. And also make sure transaction data and consistency are maintained and can be monitored. Meaning transaction data, for example, logging, whenever a request comes here, whenever an error happens here, during mapping, let's say, you have to log everything out there so that you can later monitor them. Also consider whether the anti-corruption layer needs to handle all communication between the different subsystems or just a subset of features. Meaning, if let's say this microservice that we have here in the bottom is actually very sleek, it's very neat and designed pretty well. And that means we can directly communicate to it without an anti-corruption layer in between, because we're satisfied with how it works and we label it as not corrupted. But for everything else here, we can use the anti-corruption layer and it's totally fine. So it's basically tells you that you need to think which parts of the old system you would consider as corrupted. All right, guys, this is it for today. Shout out to our sponsor of the video, Eraser, which is basically this beautiful blackboard that you're seeing here. Go check out their website. I'm pretty sure you're gonna love it too. And also shout out to our one and only member of the channel, because for now, this person is the only one, and you can also become one if you become a member of the channel by pressing the join button. All right, I will see you in the next video. Goodbye.